We have a MacBook Air, and this is coming in. Says computer won't turn on, charges but cannot turn on. So it says when you're working on a machine, when you have a machine that needs to be repaired, the first thing you want to do is you want to make sure you have all of the details of that machine. By details, there are two forms. The details comes in two forms: details from the client to tell you exactly what is wrong with the machine. And when the client gives you the full breakdown of exactly what is wrong with the machine. So I'm saying there are two details that you require. One is from the machine, and then the other one is I'll talk about the other one. The first one is the details from the client to say, okay, this is exactly what is wrong with my machine. Now, how do you manage that details? If a client comes to you and says my machine does not power on, or the client says to you that my machine powers on but it has no sound, you must establish with the client a common ground. What do I mean by that? If the client is bringing in a machine and he says it has no sound, you must confirm with the client. The client must be aware and you must be aware. There must be a common understanding between you guys exactly what is wrong with the machine. If the client brings in a machine, no sound, before you even go to address the no sound, establish that yes, indeed, that is what it is. Do not begin the repair and then you say, oh, actually, I found after opening the device that the device does not. No. So, no sound, establish with the client. Okay, you power on the device, you see that it has no sound. Now you can start your work. Then do not accept things like, I'm not sure what is wrong with it, just check it out. No, don't do that. Let them tell you, they're the owner of the device. Let them tell you exactly what is wrong with it. But I don't, okay, describe in whatever form, in whatever term, what are you experiencing as regard the device. Now, when they say to you, I don't know, just figure it out or just check out what it is. If you fall for that, the issues that you will address on that machine might become unending, and you may not also be able to coach the client. Say, for example, the client, the machine, it's liquid damage, for example, and also whenever a client say to you, my device is liquid damage, you again want them to specify: is it a liquid damage partially working or liquid damage dead? They need to specify. You just, if they say it's liquid damage, no, you need to specify liquid damage, and then afterwards, what has happened? The device is still working, the device is not working. If they say just check it out, it means that if you pick up, say for example, the keyboard is faulty, the trackpad is faulty, the machine does not turn on, and you quote them that the device does not power on. After you fix that, and then you say, also, by the way, you need to replace the keyboard and the trackpad. Like, yeah, but um, the code that you gave me, doesn't that include all of that? So no, I figured that keyboard and trackpad wasn't working only after I coded you. Yeah, well, I told you to check it out. I don't know, so I cannot pay more than that. The point is, instead of you going into argument with your client, make sure before you start working on the client's device, you and the client, you have a clear ground on exactly what is wrong with this device and what do I need to do. That is something that you need to make clear before you start working on it, and make sure that whatever the client claims the issue is, you and the client can confirm that. Not something that they say, okay, I don't know. And also, there is another thing that people say, which I personally do not take. Things like, it's fine, I trust you, just go check it out. No, 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 no. If the client sends a machine and then they say the machine, I'm not sure, just check out to confirm what it is. Okay, that is a bit fair. You check the machine and then you can say to the, now this is before you work on the machine. You check the machine. Oh, I checked the machine, but the machine does not charge. Or I checked the machine does not power on. Okay, I trust you. You can go ahead. Ish, that's a red flag. So if they send the machine, they say, I'm not sure what is wrong with the machine, you check it out. Now you checked it out, you said to them, oh, it doesn't power on. Oh, okay, I'm not, okay, I trust you, check it out. And now you come so that you and I can confirm that indeed it does not turn on. Don't work on the machine yet, because the fact that there was a bit of a pause and a bit of a, yeah, okay, it's fine, I trust you, go ahead with the machine. Nah, it doesn't turn on, but I'm going to leave it. When you come around, you have a look at it. I would like to show you the state of the device before I work on it. The mic is on. Only then will I go ahead to work on the device. Do not let them play on your intelligence and say, yeah, it's fine. No, no, no. Okay, you've checked it. It doesn't turn on. Oh, okay. Okay, I trust you. Go ahead. Now, come see that the device doesn't turn on. This is let you and the client be on the same page. So that is that. The second part of it is that is between you and the client. Make sure that is clear. Now, the second part of it is the knowledge is the device knowledge, which is something that you yourself have to have. You need to know exactly what device are you working on. What device is it? Is it a MacBook Air? Is it a MacBook Pro? Is it an iMac? What year is the device? Now, the reason why this is so important is there is no complete book or a knowledge or an educational curriculum that allow you to become a full advanced Apple technician from start to finish. Most of the knowledge it's gathered along the line. Yes, you have to be a computer engineer, you have to because you are dealing with accidental repairs. And accidents are something because of the word itself, accident. It's something that you cannot predict. You cannot exactly tell, or you cannot exactly write out a book of. As you can speculate on possible accidents, but you will not be 100% accurate, which then means that every device you work on will give you something new. Now, if I work on a MacBook Air 2013, 2014, and I know that the 2013 and 2014 they are 100% identical, which would then mean then I then need to understand that the parts between them are basically a swap. I can swap parts between them without issues. It helps me to understand that whatever failure that I tackle in the 2013, most likely I can use the same methodology to tackle a 2014. But a 2015 is going to be different because the 2015 board is outside the 2013, 2014. I cannot, for example, I can swap SMCs on the 2015 and 2017, and it's going to work for me. I can swap SMCs between 2013 and 2014, and it will work for me. I cannot use the 2013 SMC or 2014 SMC on the 2015. Do you understand? And then also you need to know the devices so well that when you're talking to your client, say for example, a client phoned you and they say I have a MacBook Air, and then you ask the client, the reason why you ask them, obviously, two things you want to ask: what is the model machine, what is the model number? Because if you ask them what's the year of the device, 99% of the time when you ask a client what's the year of the device, they give it the year they bought the device. They don't understand that the device itself. So you ask them for a model number. Sometimes they say to you, I have a MacBook Air and it's a 2016. It's 2016. Now, if a client said to you that I have a MacBook Air, it's a 2016, it's a 1466, what would you likely say in that regard? If a client phones you and say, I have a MacBook Air, and then say to them, what year is it? And it's a 2016, and it's an A1466. What will you say? Yeah. That information itself, is it correct? Why? Yes. Yeah, you are even more wrong than the client. So A1466 starts. Actually, you should phone the client, and the client should help you. So A1466, it's a model that Apple uses from 2012 till 2017. However, there is no 2016 Air. So the 2016, it's an open gap. So when a client, so it's either 2014, 2015, 2014, 2013, 2012, or 2017. No, you're not listening to what I'm saying. A1466, it's a model that Apple uses from 2012 to 2017. If a client say I have a MacBook A1466 and it's a 2016, the information itself is wrong because that's a gap year for MacBook Airs. You understand? So there is no 2016 A1466. You understand? And then also if a client calls you and says, okay, I have a MacBook Air and I need to buy a charger and I need a USB Type-C charger, what will you say? I have a MacBook Air. It's it's an A1466. I need a Type C charger for my MacBook Air. What would you say? Say again. You're getting it wrongly right. Yes, you can use a Type C charger in a MacBook Air, but not A1466. So as you know, only from 2018 and above. That's for the MacBook Airs, and then obviously the MacBook Airs now they have three chargers, correct? They have actually more than that. Okay, so I'm trying to be recent, but before now they had the Safe One, the Safe 2 from 2012, and then the MagSafe, no, the Type C, the USB Type C, and now the MagSafe 3 with the M2 Airs, M2s, and then the M3s, MacBook Airs. And then, as you also know, do you remember that the MacBook Airs also now has a 15 inches version? Yes. Yeah. See, so that's one of the downsides. So that what I ask him now, it's something I have asked him to do about, I think, 2 months ago, and he still doesn't know it. Because if you followed about this Mac, what is it called, the Mac specifications, you will see it. And even when I ask you to go on the Apple side and then look at the spread out, so exploded view of machines, you clearly see it there. 13 inches, Pro 14 inches, 16 inches, as you will see it. These are knowledge that you need. So you need to understand that in this field of ours, this is a field that requires you to be 100% accurate in your information, because that helps you to deal with your client. If a client tells you, "I've got a MacBook Air, it's an M3 and it's a 15 inches," if you yourself don't even know that there is a 15 inches MacBook Air, you probably start arguing with the client. You probably want to claim that you know. Now you tell the client, "No, there is no MacBook Air 15 inches." And then the client will the client will probably be confused, because they'll be like, "Oh, but I thought it's a 15 inches." Now, the reason why they are confused is because they believe you know. To them, they didn't know you actually another client. They need to help you. Please follow your work. I don't know. Sometimes I'm so confused, because in my time, if I had the materials you guys have, sure. No, tell Shahid that I don't know what Shahid does at home. I don't know, and I don't know what Shahid will make you mad. If even his computer to use it, you have to use it for him. I don't know. I don't know. Okay, please go through the work, so that you need to be so detailed, because that is how you can tell a client, okay, this is what you need, this is what you don't need. That's how you can interact with your client. If you don't know, what are you gonna say? Yeah. Okay. Anyway, so two information I say: first, make sure you have an understanding between your client. It's good to avoid arguments. You understand? And when it comes to client, you never win, because if you win the argument, you lose the client. If they win the argument, you still lose the client. Because if they win the argument, then they don't trust your work. If you win the argument, they just go. So the best thing is find a way that you have an understanding with the client. The client says, "Okay, my machine," and by the way, there's a common misunderstanding. When they say my machine is not charging, there are two informations in that. Number one is the machine powers with an adapter, with a charger, but it does not charge the battery. It's not the same as the charger does not power the device at all. Do you understand? Because you might get the device, correct? The device does not power with the charger, and the client's battery is also faulty. So if you fix the problem of the device not powering with the charger, and then as a client now you have to replace the battery, what do you think the client will tell you? That you don't understand the problem. No, the client will say it's the same thing. Do you understand? Because there are two issues. If the client said my machine is not charging, you should be able to understand, is it that it does not power with the charger, or that the battery is not charging? So with that information, you should see, this is, I'm just going to show you this. See here, I'm going to click on quickly. Plug in, okay, now it's charging. So before it changes, you see that sign? Before you get that sign, you see before you get that sign, you see that sign? That shows that, you see now it says that is what? Now it's charging, correct? Okay, so let me see, before it starts to charge, disconnect. You see that battery is not charging. It's still obvious. It's now it's charging. Yeah. Now that the fact that you get that information to say that, let me disconnect it again and then connect. Battery now, the fact that you see that, it means that there is a communication from the charger to the machine. Now there are two things now that you need to worry about in that regard. Yes, it could be that the charger that you're using is faulty, yeah? But the fact that you get the charger, the device recognizes power from the charger, it means at least you don't have issues with the charging port. Do you understand? You might have a situation where the battery itself is faulty and the device does not power with the charger. So, which would mean, like the situation we had yesterday, the battery powers on, but when you connect to the charger, there is nothing to tell you that the battery is what? The charger is connected. Also, depending on the operating system that you have, if you do not log into the operating system, at the lock screen, you might not be able to see this. You understand? So, but how do you go around that? You can just put the device into recovery, because in recovery you will see it. Do you understand? Okay, so that is that. So when the client say, "Oh, my device is not charging," you just want to ask them, "Is it that it says plugged in, not charging, or that the machine does not detect the charger at all?" They say, "Okay, I don't know." Okay, so bring it. I will assess it. When the client brings it, how can you easily determine both? Disconnect the battery easy. See if it powers with the charger, and make sure you're using the charger that the rating is equal to or higher than the machine. Equal to or higher than the machine. How do you know where the rating is? It's going to be at the back of the machine, correct? So here you see it says model number, and then you see the rated for 14.8 volt, 85. Can you see that?
Yeah.
You see that? Rated. So you want to get a charger that it's equal to. You can come close, then it's so that you see what it. Because I don't want you to give client wrong information and you say I told you so. Um, so it should either be equal to or higher. Yeah, because if you get something lower, chances are that sometimes there's what they refer to as power balancing. So power balancing is basically where your battery supports your charger when you don't have enough juice from the charger. You connect it. You need to, if it is that it doesn't charge, if there is no power at all from the charger, then you know what you're dealing with. If it powers from a charger but it doesn't charge the battery, then you now know what it is that you're dealing with. Obviously, there are other processes you're going to follow. Plug in another battery to see if it charges. If it's a machine that goes through a dual battery communication system, the first thing you want to do is replace the data cable, correct? To see if it's so, or check the other side of the data cable to see if it's still properly connected. Well, anyway, this is that about that. So this is coming from another repair company. They say that the device does not turn on. We know because this is a MagSafe 2, this is going to be from 2012 up until 2017. Okay, so the next thing we are going to do is because the device does not turn on, we are not going to connect power to it as yet until we define what state the device is in. In order for us to define the state, we need to open up the back of the machine. So let's quickly do so. To open up the back, we are going to use a P5. And if this is the first time you're doing this, understand that the screw sets are not going to be over the same sizes. For the A1466, the screws, they are pretty easy to identify. So you almost wouldn't miss them. You need to be a very wicked person for you to use this screw here or here. You need to be very wicked, because I mean, I don't know. You need to be very wicked to do that. So Anyway, so that's that. Okay, so the back cover is out, and then the first thing that we notice is this is definitely a 2013, 2014. The reason why we say that is because of the JTAG, correct? So the reason why we say that is the 2013, 2014 is because of the JTAG. If this was a 2015 or 2017, this JTAG, it would be half of it. You understand? This connector that you see here, if this board was a 2013, 2015, 2017, it will be half of the size. So still the size is yeah. Yeah. I'll show you what I'm talking about. So this is a 2017 board. It's gonna fit exactly, but look at the JTAG. It's way smaller. Yeah. So this JTAG is only used on 2015 and 2017. While this one is what you will find on 2014 and below. You understand? Okay. So this is a 2013, 2014, and it's coming in for no power. So we are just gonna look at it to see if there is any reason for us to not connect power to it. If not, we are not going to connect power to it. Now, another very common thing is sometimes you might find a device will be in soft reset. So in that case, when you connect power, basically it will lock you out in a way that you connect charger to it and nothing happens. So you just need to disconnect the battery, and then you can now connect power, and then then if it's in that state, then the device will start working. So we are going to disconnect the battery, and then we connect power to it. Let's see. So we don't have a fan spin. And then another thing I want to mention on this particular one, which is something very important. Okay, please note this. So this is a 2015, I say, and 20 what? 17, correct? Yes. Jawad, are you with me? Yes, I'm with you. Okay, 2015, 2017. There is a behavioral difference between a 2015 and a 2015, 2017 and 2013, 2014 in the fan management. Now, the 2015, when the fan spins, it starts and it continues without any stop. The 2013, 2014, the fan will spin, stop, spin again, stop. Only the third time will it start to spin at a go. The 2015 and 2017 does not do that. If the 2015, 2017 does that, the device will not post. If it does that, you have a problem. If that behavior on the 2013, 2014 is standard, it's okay. Is it clear? 2013, 2014, the fan behavior is not the same as 2016, 2017. What am I saying? 2015, 2017. 2016, 2015, 2017, fan will start at a go and it's not going to stop. Do you understand? Aha. However, with the 2013, 2014, the fan will start, stop, start, stop, and then the third one, it's now going to do what? It's going to continue. Talking about fan speed, you know, we have the regular fan speed and irregular fan speed. That's a whole lot of topic that we need to go into. But in order for us in order for me not to confuse you guys, I'm just going to mention just two things. Yeah, if you do not have the IO board cable connected, your fan is going to ramp up. Your fan is going to be loud. Correct? If this cable is not connected, your fan is going to be loud. If your trackpad cable is not connected, your fan is not only going to be loud, the device is also going to be slow. The device will lag. The difference is, if your IO board cable on the A1466 is not connected, the fan will be loud, but it's not going to lag because there is no sensor involved in that. When your trackpad cable is disconnected, the fan will be loud and the device will lag because now you have a sensor issue. Do you see the difference? Yes. The IO board cable not being present, fan is going to be loud, but your device is going to work 100%. Yeah? Trackpad cable not being connected, fan will be loud, device will lag. Do you understand? Now, I don't want to go into this, but I just want to quickly go into it. Fan management, when your fan receives the power, the power voltage. Okay, let me not do that, you guys will mess it up. Okay, let's just take it just this one. So when we talk about fans, then we can go into it in details. Let's just understand it again. Let's just basically recap. 2013, 2014, the fan management is such that the fan will start, stops, start again, stop, and then start for the third time, and then that's when it continues. The 2015, 2017 will not do that. It starts and it's a one, it's a one spin, and that, and then it continues. If the IO board cable is not present, the fan will be loud. Not only will the fan be loud, whatever functions that are present here will not be active. For example, the audio jack will no longer work because there is no communication to the board. The USB that is there will no longer work because there is no communication. However, the one thing that will work is still going to be the DC jack. The DC jack will work, but there will be no LED. You understand? DC jack will work because DC jack still has. So on this one, if I disconnect, you see there are two connections now, that cable and the main power. Now the main power is still going to be active. Now the other peripherals are going to be active with the cable. So if you don't have, so whatever is here with the cable disconnected, for example, this speaker will not work. And also with this cable out, the audio itself will not work. There will be no audio. Why? Because the audio IC on this machine, on this particular machine, is on the DC jack. You understand? So the audio, so it's not going to work. So that's just how you can tell the difference. And also the LED will not be active. Okay, so that's about that. Let's quickly continue. So this is coming in for no power. We see that we have LED on the charger, so which means that we have PP342 correct, and which also means that we have PPDC in. Okay, so let's just put that back and see what, do basic measurement to understand what is it that we have and what we do not have. Okay, so we have our black probe on ground and then our red probe. Charger is multimeter set to voltage mode. Let's see what we have on our PP bus. PP bus is 8.6, so that means our SMC is also active, correct? Because if it was 8.2, it would mean that SMC is what? Is not active. So let's check on both sides of the fuse just to be sure that we don't have a blown fuse or short on one side. That's good, we don't have, and that is fine. So let us see if the device is partially making its way into SO state. We can check on this inductor here. Let's see what we have, and 0 volt, nothing. Okay, now let's see, do we have the source rail present? We don't have. We have let's see that. Let's see, 1 volt. So we're supposed to have 3 volts there, but we're getting 1 volt. Okay, anyway, and we can also see that the source is what? Is not present. So so what we are quickly going to do now is we are going to take the board out. So that was basic. That was a basic measurements. Now we know we don't have an issue with the PP3V42 line. We don't have an issue with our PPDC in. We do not have an issue on our PP bus line. However, we don't have our source rail present. That is a critical rail without which the device is not going to start. So, and we also see that we are getting 1 volt on a 3 volt line. So we are going to check to see what exactly is happening. So to do so, we quickly take the board out. Uh, Whoever took out the board before, they didn't put the screw that's supposed to be here. It's not present. Yeah. Okay, so board is out. And it's important that this comes after the screw is installed. Yeah. So this, even though the screw is missing, but this should only come after the screw is installed. Okay, so the board is out. Let's open up the board view real quick, and I'll show you guys what is it that we have measured and why that is important. The board number also the board view. So the board number. So I suppose Shahid will also show you how to identify the board numbers. The board numbers, the general board numbers, the general numbers that they all start with is 820. That's general across them. So you just have to look across the board. Come close so that you see what I'm talking about. So you generally look across the board to see where you find the board number. So for this one, it should be under there, the SSD. It's my P5. Okay, so that's the board number. 820-3437. That is the board number. So if you are to load this on your on your system, this is the number that you're going to look for, 820-3437. And then, by the way, you can use this 2016 board view. It's fine. Sorry, I keep saying 2016. You can use a 2015 or 2017 board view. It is fine. So we are actually going to use that, or we can get it on. But let's see, whatever it is that we have here is what you're going to use. Whatever is already open once. So this 00165, that it's a 2015, 2017. And the 3437, do we have it open? No. So let's just go ahead and use that. So this is the board view, and then let's quickly open up the schematic. Hopefully the schematic is still present, because these days I see most of my schematics are not present. 165. Okay, we have it. Okay, so here, so what we, this is now this is a summary page of the rails that are on the machine. It's a summary page of the rails that are on the machine. So if we say, let's go back to page 1. Now here on page 1, that's from here you can look out to see where it's the voltage page is on the schematic. So if I zoom out, you have your one, it says table of contents, BOM configuration, BOM variance, PD part, CPU, blah. Until what I'm looking for, it's my power, the way it says power. So there it says what? Power aliases, not signal, power aliases. And then it's on page what? 62. So I'm now going to say go to 62. Okay. So it's we are going to stop there, and then we'll continue after that. Okay, let's quickly go back here. I'm just going to show you guys what I did and why I did what I did. So when we started, quickly, I checked for a couple of rails. So the first thing I did was I checked for a PP bus rail here. Why did I? So here on my fuse, I didn't mention that whenever you see the F, it stands for fuse. Okay, so when I checked for PP bus here, I found my PP bus was present, and then what I also gathered from measuring this one was also that I got 8.6, correct? Now 8.6 will be that the SMC is given a go ahead on the PB bus voltage to go make its way to 8.6. If the SMC was not communicating, we'll be getting 8.3, not 8.6, either 8.3, 8.2, but not up to 8.6. Now, the fact that I have 8.6, it tells me that SMC is doing its work, at least to that level. The next thing I did was to also check, because this is a fuse. A fuse is like a wire. If it's a wire, whatever I measure on one side, by default, it's going to be on the other side. But sometimes you might have a situation where you have a short on one side of the fuse. If that happens, it breaks. When it breaks, you will have voltage on one side, but no voltage on the other side. So I just again checked to see that I have voltage on the other side, and that I found that I have voltage present. The next thing I had to do was to check on my L7550. L7550 is an inductor on an post SO rail. So when the device is on, you should have voltage on this line. Now, I previously, okay, I'm just going to go to something, but let's quickly deal with this one. This is whenever I see L, it stands for an inductor. In terms of behavior, an inductor, in terms of measurements, if you find voltage here, you must find voltage on the other side, because with an inductor, both sides will be equal. Just like your fuse, how both sides are equal. An inductor both sides will also be equal. Now, this voltage here, the one that says PP, so it says here, PP5V underscore S4RS3 CSN1. Now, if you are to decode this on this line, what are you supposed to have on this line? 5 volts. So you're supposed to have 5 volt on this line. S4 and current sensing. So SCSN1 and N1, that is current sensing. Okay, so we're supposed to have 5 volt on that line, and that is a post SO rail. So if I measure 5 volt on this line, it means that my board is actually trying to start. Do you understand? Because it's in SO state. It's in a state of on. Do you understand? Now, I mentioned before that whenever you see this point here, XW, that's a point where a signal makes its way from one side of the board to the other side. So like this. The signal makes its way. So with XW, it's different from it's different from this. At the surface, you will see a test pad, but at the surface you do not see an XW pad. It's usually hidden. Okay, but that's that. So what we did again, so we measured for voltage here, we found we have voltage here. We measured for voltage on our L7520, we found that we have 0 volt there. The next thing we did was to come here to check to see if we have a source rail. Now the source here, we checked to see if we have source, PP3V3 underscore source, and that was not present. Then the next thing we did was to check to see if we have a 3 volt line here on this capacitor here, PP3V3 underscore S5, and then we found that we have, what did we have here? We're getting about 1 volt here. When we measured here, we're getting about 1 volt, correct? Now, what am I supposed to get there? What am I supposed to have here? 3.3 volt, correct? Why? Because it says PP3V3, correct? So you're supposed to have. Now, when you are to the equation of the voltage is just from the start of the digits to the last of the digits. Doesn't include the other is the state, and then you just remove the V, place it on the other side, use it as dot. PP3V3, then it becomes 3.3 volt. You understand?
Can you read this way also?
Yeah, that's it also. So that is the voltage, 3.3 volt. You understand? So it's 3.3 volt. Now, when we measured here, we got 1 volt, correct? Instead of 3.3 volt. Now, there's something else I want to mention. See, when we checked here, PP3V3 underscore source, we were getting what? 0 volt. And here we have 1 volt. If I am to start my troubleshooting, where do you think will be the easier place for me to start from?
3.
No, so where do you think will be the easier? Here I'm supposed to get 3.3 volt. I'm getting 1. Here I'm supposed to get 3.3 volt. I'm getting 0 volt. Where do you think will be the easier place for me to start from?
0.
No. Yeah. Should I start from this rail or this rail? This one. The easier one will be to start from this one. Because the fact that you're getting something, it means that you have a direct starting point. You're supposed to get 3. Now, the reason why I wouldn't come here directly is this has sub-rails requirement. So this rail here that is not present, there are other rails that are required to be present before this will be present. Do you understand? So this will be more broader.
Yeah, it will be more complicated.
Exactly. But this is easy because now I see that I'm supposed to get 3.3 volt here, but I don't have it. Then I can just quickly go to, because along the line you will find the interesting thing about this is the source rail of what's required for the source rail to be created is also this one.
So it must be the same.
No. Of the requirement of the source. Of the requirements of the source. Of the requirements of your source rail to be generated is also this rail here. So the fact that this is not present, definitely this will not be present. Do you understand?
Yes.
So I have to first find out why this is not present. Is it making sense? Okay. Anyway, So pp3v3 underscore s5. So how do we find where this what do we do from here? What now we know that we have we have 1 point something volts there. Then what do we do to narrow that down? Yeah, so how do we do it? What do we do from here? So where should we type it in on our board view, on our schematic? Okay, so we go to C8130. Okay, so let's go to the schematic, and then we type C8130. Okay, so C8130. And what is it that you are missing? PP3V3
It's fine.
underscore S5. Now, so we're missing this volt, this rail here. So what do we do? This is now we know that this rail is not generated from here. This is only a product from somewhere. So how do we know where this is coming from? How do we know where it's coming from?
I should look at this minor source.
So you see this circuitry that you see here, this is what we are missing. We are getting 1 volt here, correct? However, this is coming to power this U8130. This here is not generated by this guy. This is coming from somewhere. How do we know where this is coming from? I'm asking you, how do we know where that is coming from? How do we know where it's coming from? I'm waiting. When you watch the videos, what do you watch? So two things. Is either you don't watch the videos, or you watch the videos but you don't know what you're looking at. Because we have done that in details in the video. In details, we have done that. That is why I don't like, that's really why I get pissed with you, really, Shahid. Because you have the materials, you choose not to use the materials, which is so unfair to yourself, even. Okay, well, it's for your own good. If you choose to remain where you want to remain, good for you. Okay, so we have a rail here that is missing, and then we can confirm that this is coming into it because it's not being generated by U8130. Now, we need to find out where this is coming from. In order for us to find out where this is coming from, a small hint. So, you see the numbers that you have here, the numbers of pages that we have here, it tells you that these numbers of pages, you will find this signal or this rail present in these numbers of pages. Yeah. However, if we want to, so we can manually type in 34, we will find this there. If we type in 29, we'll find that there. But that's not what we're going to do. How do we work our way back? We will copy this, we copy it, and then we paste it in our search. We copy it, and then we come here to do what? To paste it on our search. It's because we want to check to see where it's what is being generated from. Now, it says here that it's found on 21 pages, correct? Now, what I'm now going to do is now I want to see where it's coming from. I want to see where it says out. I want to see where it says out. Here it's just on a line. So it's going into something. It's not coming out of here. So this is not where it's being generated from. Okay. So then I'm going to say nest. Now on my next page, I will look. Now also here, it's coming into something. It's not coming out. I want to see where it's coming out from. Okay. Then I want to go nest. Okay, this is flipped. It's definitely not here. Then nest. This is also it being on what is it on the resistor. That's not where it's being generated from. Just use it so that you see it, and then I go nest, and then here this is also it going into something. This is not where it's coming out from. You see, it's not coming out from there, and I go to nest again. Now on my nest, this is also where it's going into something. It's not, yeah, the same thing here. It's part of a line. It's not coming out from there. The same thing here. It's going into something, not coming out of something. We go to nest. Did we not do this before, Shahid? See, when you really want to do this, if you are not serious about it, you will just be there like a just regular person who claims he knows how to fix computers, but he doesn't really know what he's doing. He can do basic stuff, but he doesn't really know what he's doing. You have to be serious with this. If you're not serious, I don't see how. Because if it's been done before, but you choose not to follow up, you don't even know what to do. That's okay. So here, you see here, here you see this is an equal sign. So this is an equal sign. So this is also not where it's coming out from. This is not where it's coming out from. This is it's also going into something. We are looking for where it's coming out from. It's not coming out from here, nor here, nor here. We continue our search. That is also going into something. It's not coming out from there. Now, here it says, so here it says 3.3 volt WLAN and LAN switch. Now, here it says also what? What does this? What do you see there? What does it say? What does it say? Voltage in, V in. Correct? What we're looking for is where it's coming out from. Correct?
I should look something like this, like on the left hand side.
Yes. Yeah. That's yes, exactly. Now, when we come here, this is also where it's going into something. Correct? It's not. That's not where it's coming out from. Here is also going into something. It's coming out from there, and U4500. This is also it going into something. It's not coming out. You see, going into something. Because you see how that's where it does so much, and then also part of that it's you find it on your U5000, which is your SMC. Still, that's not where we want it to. That's not where it's coming out from. So if you see here, you also have what it says P3V3 underscore, and then this is okay. This is a reference out voltage, and then it says PP3V3. Now, but there's something I want to show you guys. So you see here, PP3V3. Now you have it also on your on these capacitors here, correct? Okay, let's see. There we go. We still have it on something. Okay, and finally we are here. So what does it say here?
Voltage out.
Now voltage out 3.3 volt. Now this is the line. Now let me. So one of the easy way you want to know where a rod is being generated from. Usually there will be an inductor. By the way, remember this person's machine, Jacob. How are you? Good. You want to collect the 14 inches?
Yeah, you said it today.
Okay. So what do you want to do?
We have a plastic ready to use.
Okay. Help him out. Okay. So So here it says V out 3.3 volt, and then you can another thing usually is you will see that it will precede an inductor. You understand? This is a circuitry that takes a high voltage, switches it until you get a low voltage, and then that will be the after product of an inductor will be required to put at the end of the circuitry. Don't worry about that as yet, as to how, and just don't worry about that for now. However, this is where we're coming to. The voltage that we get out is what? That we're supposed to get is what? 3.3. Now it says 3.3. Now underscore, you see reg. You see all of where we're coming from, we didn't see reg. You understand? So reg is regulator. So it tells you that it's been regulated from here. You understand? So all of the previous is that we are coming from, you will see that there is nothing that will say reg. So say for example, if you look at this line here now, this is 1.8 volt regulator circuitry, correct? You see here, and you see it will be after an inductor because of the way a buck converter works. It's going to go through switches, yeah, and then obviously after an inductor, then you get your 1.2 volt. It takes a high voltage and then you basically turns it into a low voltage.
Can you simplify an inductor?
Okay.
Is it like the whole thing together?
No. Just this. Whenever you see L, you see the way this is a sign. This is how it looks. This is how an inductor looks, and it's going to be U. It will be L. For example, this is L7820. So whenever I see L, that tells you that is an inductor, and this is how it looks. That's a symbol for your inductor. So if we check here, for example, you see this is PP3V3 underscore S5. You don't see reg there. So, but when you, for example, where you see with this one, with 1.8, we see here, it says 1.8 S3 reg. That's where it's being regulated from. Do you understand? So the same thing applies to the page that you're coming from. You see, it says PP3V3 underscore S5 underscore reg. All other ones, we just see S5 or being attached to something, but we don't see reg. So this is where it's been generated from. So the next thing now we're going to do is we are now going to go back to our board view to look at how does U7501, how does it look like? And what is required for U7501 to give us what? 3.3 volt. Do you understand?
Yes, so you allocated the
yeah, so now we are now going to come to the board view to find out what is that, this component U7501. We are now going to find out what does this require to give us that? What do we need in order for us to get the 3.3 volt that we are currently missing? So now we're going to go to U7501. So we can just copy that U7501 and then paste it on our board view, and then it will show us the chip that is U7501. Now this is the chip that is U7501. Now we are not going to locate that chip. So far, is it clear?
It's pretty clear.
Shahid, on your side, do you understand what's happening? Huh? I hope so. Okay, so now we are going to locate which is U7501, and now this is U7501.
How do you know that one?
Okay,
you say
so,
U7501 there.
No. So you have to. This is the board. This is the board. Correct?
Okay, so this one, yeah.
Yeah. So this is 7501. So if I zoom out just a little bit, so this chip here is this one, correct?
Yeah.
And the next big one will be this one, correct? And the next will be this.
Correct.
Below it will be that. These two capacitors will be this. And then if I come to this side, will be this, which is this one. Below it, I have a big capacitor, two smaller components on the side, two smaller on the side.
It's simple to find it now.
Yeah, you understand?
Yeah, I understand.
Okay, so so this is U7501, and Remember we said that we are going to look to see what is it that we require in order for us to in order to get the 7501 to do its work. So even though there is no oxidation or corrosion, just like what we find here, so this is going to be a problem. See all of that, that's going to be a problem. And also that line there, we are going to look into what that line is. And then we also have this resistor here that are not looking so good. Okay, so now let's see what is happening around the 7501. So let's have a connect power to the board. Okay, so let's establish what we have, PPDC in voltage. So that is to establish that we have voltage coming from the charger. So we check for PPDC in, and that is present.
Should we put the red one? Oh,
The red one
yes.
on the pin that I intend to check what voltage is on. So if I go to the other side of the board, when the DC jack is connected, it connects to this it plugs into this connector here.
So you're just checking if it's operating.
No, so what's happening now is this is a connector, which is this one. Now, on that connector, you see that I have, it says PPDC in. You understand? Now, DC in, it's your charger. The voltage that comes from your charger is your DC in, correct? Now, this pin here, you see, when I click on 1 and 2, it tells me that 1 and 2 are the same because it aligns to be the same. In order for me to confirm that I have voltage coming from my charger, I set my multimeter to voltage mode. My black probe will be on ground. I can use this as my ground. This can be my ground. This can be my ground. This can be my ground. Whatever is easier, convenient for me. So I use this as my ground, and then the red probe will go to that pin, or either pin 1 or pin 2. So, which is then I do this. I use my pin 1. So that tells me that I have voltage coming from my charger. You understand? Now, the next thing I want to do is we already confirmed that we have PP3V42, because if we didn't have PP3V42, we would not have PP bus being 8.6. So we have PP bus being 8.6, and definitely we have PP3V42. Now, why we are here is because we are having 1 volt here instead of 3.3 volt. Now, let's go find, we know now that that is a rail that is supposed to be generated by U7501. Now, let's see, what do we need for U7501 to function? So, U7501 to function, so we are now going to start from the first pin. So, we are going to see what we have on pin 1 of U7501. So, if we go to the other side of it, so pin 1 of U7501, it's going to be this side here. And that is 0 volt. We'll move on to pin 2. And then also another very easy thing you want to do with this one, you want to just, to make it easy for you, just go see what you have on your V in, voltage in, correct? You check that, and then you check the EN, the enable signal. So basically, this whole circuitry, it will have an on and off switch. On and off to turn the switch, to turn the circuitry off itself or to turn it on. So the on and off switch will be secondary. The voltage coming into the chip will be primary, because in order for the switch to work, you have to have electricity. If there's no electricity at all, even if you flip the switch, there will be nothing. You understand? So in this case now, let's just go and check our voltage in. That will be easy. Let's check pin 23. So we come to our board view and see where is pin 23 on our board view. That is pin 23. So we can check this capacitor here, C7500, to check for our voltage in, which is this capacitor here, to tell us if we have voltage in. And then yes, we have 8.6, that's voltage going in. The next thing we want to do is we want to check the enable signal that we should find on pin 12. Yeah, so pin 12, it's the enable signal. That is the switch to turn the circuitry on or off. So let's see, we're supposed to get 3.3 volt on pin 12. Let's see if we have 3.3 volt on that pin 12. We can either measure it on this on a TP, which is a test pad here, or we can use this resistor here to check for the voltage, which is R8140. Whenever you see R, it stands for resistor. So we can check to see if we have that voltage. We're supposed to get, you see where it says 3.4 volt, we're supposed to get 3.4 volt on that line. And obviously that's when you have power on the board. So now we want to see if we have 3.4. So we can use this resistor here to see if we have 3.4 volt, 3.3. Yeah, that's enough. Okay, so the next thing is, this capacitor here, let's see what is it that we have on that capacitor. We're supposed to have 5 volt on that line, and yes, we have 5 volt. And then let's see, let's just confirm again that we have 1 volt here. Let's confirm that, and we still have 1 volt. So what we are going to do, because we see that, so let's quickly check what do we have on our clock circuitry. Let's see, we have 3.3 volt. Okay, now that's let's see, so this guy here, Y1905, it's not looking good, so we are going to redo uh, so we are going to redo this. So we are going to redo this section here, and this not so much, but we are going to redo that. And then let's see that, so that is also not so much. Another thing that we forgot to do, uh, so what we are going to do is, before we continue here, as you know, there are other voltages that are going to be required, or other requirements for U7501 to function. So what you're going to do is, because let's first address this damage here, and then we can continue our search. Sorry. Okay, so because the way this is looking is going to obviously prevent the circuitry, especially that section of the board, from functioning the way it should. And other rails on the board will be dependent on the output that comes from here.
So one chip can like control and manipulate other chips.
So that again? Sorry.
Like one chip can
No.
control and
The
manipulate.
output of one, the others are dependent on the others are dependent on others. You see how we were looking for voltage out? It's coming from far, but that output goes to many other components, many other circuitry. So if one fails, down the line, the others that are dependent on it will also not work. Yeah. Okay, bring us another board that we can use there. You can bring 80-00165 also, it's fine, will work. Or 3437, just like what we have here. You can give us 3437 or 00165. He has to come upstairs. Otherwise, you can send Jawad to him, but Jawad doesn't know him. What? You can go drop it for him. So there's an important thing to note here. So we see that Y1905 it's damaged by oxidation. However, and then we also saw that these two resistors here. Um, so you see this and that, both being alighted means they are on the same pad, correct? So for example, even if you join the resistors on this side, it's fine because they're on the same pad. Do you understand? 1 and 2 means, okay, let me do this. When I click on this, wherever you see they are like the green means that they are of the same. Green here, green here. It means this point and this point are the same. If I click on this and then I get green here and green, it means this point and this point are the same.
And the numbers are the same, no? Like over here and over here.
How do you mean if the numbers are the same?
Like this corresponds to this, and this number corresponds to that other one.
No, this is an independent component. This is a resistor. This is a resistor. However, this resistor has pin 1 and pin 2. The pin 2 of this resistor is sitting on the same line as the pin 1 of this resistor, which is why when you click on the pin 2, it alights here also. Let me see if I can show you what I'm talking about. Bring your book. Oh, wait.
Page.
Yeah. So these are two lines, correct? So let's name them line 1 and then line 2. We have a component which is a resistor. So this line will represent resistor. This line will represent a resistor, correct? This resistor has 2 points, 1 and 2, and then 1 and 2. If I want to place this resistor across my line and my 2 lines, the 2 part that the resistor has, remember it says it has 1 and 2. So the 2 will be on this line, this 1 will be on this line. Any other resistor that comes, or any other component that comes on this line, will mean that it's sharing the same line with this resistor here, correct?
Correct.
So this line now is sharing the line with this one. So that is important. For example, if there is a break in communication between this and this, when they say break in communication, it means that the communication between this and this through this is no longer possible because you have a break in line. Do you understand?
Like almost like Shahid was showing me with
No,
backlight.
wait. That's going to be too far. Just try to understand this.
Okay. So the break will be like cross here or like.
No. Okay, so this is it. So this is one line. This is a straight line, correct? That's one line. This is another straight line, correct? Okay. If I place something between that joins this line and that line, let's say I place I place one of this between the lines. That's one. Hmm? Now I am saying that this point is communicating with the line on the top. This point is communicating with the line on the bottom. Anything else that does the same thing as this, I will say that this is sharing a line with this, because if I place this on one line and I bring something else and place it on the same line, they are sharing the same line, correct? That's what I'm trying to say.
Okay, I see.
So this is a line. This is a line. When I click on this and it highlights it, it tells me that this is also this same line here runs here. However, the tricky part of this, here you see a straight line. Here is not straight. You understand? So it goes. So wherever you now,
But eventually it does connect.
that's what this is doing. So when I click on this, it shows me where that is present. So for example, here, this same line runs to this point. This line gets also there, and then you trace it. You see, that's the line going.
Eventually you'll find a starting.
No, don't worry about starting point yet. It's just a line. You understand? The line also gets here. Okay. You get to understand, hopefully. Don't worry. Okay, so we see that we have oxidation around Y1905. Now, Y1905 it is critical to the overall function of the board. And then we have components around it that has failed. For example, we have this capacitor that's not looking good. We have this resistors that are I see those are going to be critical if they are present on the board. Okay, one of the resistor is present, the other one is not present. So R1905 is present on the board, the other R1906 is not present. Now, the most important thing that's going to happen here now is, so we want to see the communication between Y1905 and U1900. We want to see the communication. Now, if we see on this resistor here, when we click, U1900 communicates with Y1905 through pin 3 of U1900. Now, I expect when I read this point and this point, it should be complete. So it should beep. If this do not beep with this, it means I have a break in line. Because since it's a straight line, or since you have a line from this point to this point, if this breaks, if I use my continuity meter if I put my probe here and another probe here, it will not beep because it's broken. So I need this line to go all the way, and then through this resistor, and then it to now establish communication with pin 1 of Y1905. So first thing we want to do is let's go ahead and replace. But before we replace, we want to see that we have the lines are not broken. So this is how it looks. I have tried to clean it. So what I'm going to do is we are going to check to see that the pin 1, we are going to see that pin 3 of U1900, it's not broken to that. So in order for us to do so, we are going to remove U1900 as well. Okay, so that's out. Now, before we worry about, let's just put back the components that we took out from the other side. So Shahid is telling you about backlight. That is big stuff. Backlight. No, that's too much for you. Okay, so and then let's replace those two capacitors. So first we're going to deal with the ones that don't require. and this resistor here is missing. Let's see what is that resistor. It's completely off the board. See if we have the pad. Hmm. Hmm. It's completely off the board. We are going to check to see what is the function of that resistor. See if we have to worry about it. Uh, hmm. We need that. Uh, hmm. We need that. Okay, so what we can do, it's this pad, the pin 2 of it is missing, correct? But the pin 2 is equal to this one. So instead of flipping the resistor this way, we can flip the resistor that way. You understand? This pad is present, but this is missing. But this and this we see that is equal. So instead of aligning the resistor this way, we can flip it like this. So that pin 1 comes here, and the pin 2 of it will then become this.
You said it again.
We have two points for the resistor. This is the resistor that needs to come here, pin 1 and pin 2. This pin here is still present, but this pad here is not. So what we are going to do is, since this is equal to this, instead of having to replace the resistor like this, we'll flip it like this. So one pin will sit here, the other pin will sit here.
Okay, I see. And it connects.
Yeah, because this and this is equal. This is missing, but this is present.
Okay.
You understand?
So does this one matter?
Which one?
This one over here.
Yes, it does matter, but that is still present on the board. Okay, it's fine if you don't understand it. Even the pin 1 doesn't seem to be present. Even pin 1 doesn't seem. Let's see where pin 1 is coming from. Uh, hmm. On pin 1 it's a problem. See, and then pin 2. Hmm. Even the pin 1 it's a problem. Okay, so that's going to be okay. Okay, let's see. Okay, so we are gonna get to that, but for now, let's try to adjust the others. Select straight. And the two capacitors are there. Let's see what else. It's in that line. Okay, the resistor is missing. And the cap on the top. Okay, let's put that back. Resistor. Okay, I think that resistor is sitting on a double pad. There is a 1, 2, which is 1. And one left. Okay. Let's see. So we know that this pad and this pad are connected, and then this and that are connected, which then means that this. Okay. So let's see if pin 3 of is connected to the resistor we just replaced now. So B pin will tell us that yes, it is connected. So we want that to be connected to the resistor here. Okay, that's fine. And then we want that. So it's connected there. So it means the line between that and that is fine. Okay, and then we want to see that line connected to that. So let's see if it's connected. Okay, that's fine. Okay, that's fine. So which means we have communication. And then what else do we need? So that is communicating the way it should. There's nothing to worry about because it's not present on the board. So we just need that to be communicating, and it's doing that. Is this two present? I don't think those two are present on the board. Let's see. No, those are not present on the board. So we are going to find a way to replace that. But right now, let's put the clock chip back, and then also put that back. I'm going to remove some of the excess solder. Off. Okay, it's off. And then the clock chip that we took out from here. Where is it? Okay. When you're replacing a chip like this, you have to be aware of the orientation. The orientation must match. Okay, that's there. Okay, I'm gonna have my fan disconnected. Now let's check again to see what do we have. Let's see if we have any difference. Charger is connected. Let's see what's that. PPDC in, safe is present. 8.16, that's fine. PP342, 3.4, PP bus, 8.6. We are getting 1 volt here. Let's see. We still have 1 volt. Okay, so 3.3. Okay, 5 volt. Okay, 3.3. Okay, and our source obviously is not present. So let's okay, okay. So we are now going. Let's just confirm that PP3 if it's present. The clock chip is present. Okay. We the 1 volt. Okay, let's see. Okay, let's just replace that, but it's not. Let's just put in another 7501. That's an easy way out. Can you give me another is 100165 or okay, that's the chip is missing. Okay. I'm not sure if this works, but I'm just gonna test it. Okay, these resistors here are not looking so good, so I'm just going to replace them to be safe. I'm not present on this board. Walaikum salam. I'm gonna be with you now. I'm coming. I'll be with you now. Okay, let's quickly attend to him. Okay, so we have replaced E7501, and so now we want to see what is it that we have on the 1 volt line that we're getting. So also we did replace the two resistors that are here. Let me see. It looks like this guy is lifting. It's fine. Okay, so let's see if we have. Let's check the 3 volt line S5. We're getting 1.1 volt. Yeah, we're getting 1 volt. Let's just confirm. Charger is connected. Okay, charger is connected. Okay, it's PP3V42 present. PP bus is present. A 1 volt line. It's supposed to be 3 volt. Okay, now we have 3 volt, and the source line. Now the source line is present. Okay, let's see. Is the device making its way into SL state? Okay, device is making its way into SL state. So now let's connect our fan. Let's see if we have a fan spin now. Okay, we have a fan spin, so it's supposed to stop and then start again for the second time. It should stop, then the third time, then it should continue.
So it's 2013, 2014 model.
2013, 2014. Now, a bit of explanation on this. Remember I said the 2015 and 2017, the fan will just start and then continue without having to stop. If the fan does this on the 2015, 2017, it means that the board is not posted. Now, on this one, if let's say the fan started once, stopped, and then started again, stop, and then the third time continue. If it started once and stopped, and then for the second time it just starts and it continues without the second blow, or if you connect the charger and it just starts once without having to switch off and then it on and then on again, then it's not going to post. You get the difference. If the 2014 or 2013 behaves like the 2015, then it's not posting, there's a problem. If the 2015 behaves like the 2013, 2014, then there's a problem. Which is why you need to know which is which. You understand? So, and obviously, a full confirmation will be that there will be no caps lock, or there will be no chime, or there will be no display. Okay, so let's just quickly go over what we did. So we didn't have. So we checked. We were missing. We were getting 1.1 volt here on a 3.3 volt line. We're getting 1 volt, 3.3 volt line. We narrowed down where that is going to be, that is to be created, which led us to U7501 here. So we replaced U7501, even though it wasn't looking, U7501 was not looking bad. So we replace it and with another one, and it seemed to be working. And also the two resistors around 7501, also we did replace those, and we walked around the clock chip, as well as the Y19 Y1905. We also worked around that and some of the resistors that are around it. And yeah, now we have a working machine. So we just want to confirm that indeed we have display on the screen, and then that will be the end of the repair. So for testing, we just need the DC jack, the screen, and maybe the keyboard. Just because we're not going to wait for the device to boot, so we can hold the Alt key to see if at least we get something on the screen. So we can connect trackpad and keyboard cable. Okay, so hold down the Alt key. So the fan starts. Just stop. Start again for the second time. Just stop. And the third time. Now I should start. Posting. So I'm holding on the Alt key. And that's it. It's my machine powers on, and then you have a drive, and then we can just click on enter even though we don't want it to boot. We are going to disconnect once we see the app logo loading. Yeah, that's about it, guys. And so we are now going to clean it and finalize the repair. Thank you, guys. I'll see you guys in the next one.